Hey everybody. So this notebook is a synthetic irony trainer, and I've covered synthetic irony before on this particular channel. So just a brief overview, synthetic irony is essentially taking a concept and utilizing the opposite of it. So in this example, and a brief example, you can utilize and say that the sun is a cold, dark sphere, which would be the synthetic irony statement, and then the truthful statement would be that the sun is bright and warm because it's a star undergoing nuclear fusion. So essentially, you give the model like a severely incorrect statement, and then like kind of like the opposite of the truth, and then you give it the truthful statement, and then a ground truth, and then within that, I mean, it's a simple setup, and you would think that it wouldn't do a whole lot as far as the significant things within this. I've noticed within this that we get really cool results out of this. And then so I've built out this trainer, and then so here it is. Up front, this trainer takes a huge amount of resources. It is super resource intensive is the major problem with it. I have it as streamlined as I can get, so I'm running it on small LM 135M. Any bigger model, I can't do it. I have batch size severely reduced. I've got like a lot of things that are just this is a very simple implementation of this trainer, like as simple as I could get. You could 100% scale this up, and I'm utilizing the, in this instance, free Google Colab, but you 100% need the T4 enabled. So I'm using 14 gigs of GPU in this instance and just maxing it right away, even with this small model. So just highlighting up front, this isn't a resource cheap method, but the results are promising. I'll show you at the end here. So let's go through exactly what this notebook does. And so this is a full trainer. This notebook will give you everything that you need to set up and train a model using this synthetic irony method. And this notebook fine-tunes a pre-trained language model, in this instance, small LM 135M, to better understand and reason about contradictory statements, specifically targeting the identification of irony and its correction. It uses contrastive learning approach combined with standard language modeling loss. So here's the essential breakdown. The setup is that we load the model, we create our data set, and then so in this instance, we're creating our synthetic irony data set, which defines a small synthetic data set of ironic/incorrect statements paired with their corrected counterparts and explanations. And then we use the /t identifier as identifying the truthful from the ironic statement. And then we also, in this instance, create a Hugging Face dataset object from this. We tokenize on the data set, and then there's individual tokenization, which adds to the like memory usage in this instance. And then we have a data collator, which creates a custom, it's a custom collator class that, and the class takes the output of the tokenization step and prepares it for the model. It converts the list of tokenized inputs into PyTorch tensors. And this is different from a standard data collator because it needs to handle the ironic and correct inputs separately. So we're like collating and feeding in and out the data. And I had to do a lot of back and forth specifically on this, and then with this next step as well, these next two steps for the contrastive learning and the contrastive loss function. So I created a dataset loader using the tokenized dataset, and it uses the custom contrastive data collator. And it's in this instance a small batch size of 2. I can't go higher than 2, and gradient descent. And then it utilizes Atom W as the optimizer. So Atom is always in there. In this instance, it's Atom W. And then with a small learning rate and weight decay, contrastive loss, this does use backpropagation just up front. So this defines a contrastive loss function that calculates the loss based on the distance between the embeddings, and then it takes anchor positive and negative embeddings as input, calculates the pairwise distances between the anchor and the positive embeddings and the anchor and the negative embeddings, and uses a margin-based loss to encourage the positive embedding to be closer to anchor than the negative embedding. So I worked on this a lot, right? I'm essentially trying to get the model to know and differentiate very well and very distinctly the ironic concept from the truthful concept. And then we have our training loop, which again involves backpropagation. So it's we're doing it off of this based off of this contrastive loss, right? Which is in this specific instance, the ironic statement embedding is used as both the anchor and the negative example, and the correct statement is embedding is used as the positive example. And then this entire setup is a very simplistic implementation of this, right? You can get far more advanced into this, and I'll talk to you about that at the end. And then so you have at the end your 3 evaluations. And then so this performs 3 evaluations on common sense reasoning, word embedding, similarity, and abstract reasoning. This is like the main kind of guts of it. And then so the common sense reasoning tests the model ability to answer basic common sense questions, comparing performance before and after fine-tuning. The word embedding similarity examines the cosine similarity between embeddings of word pairs with opposite meanings, such as like hot and cold, after the fine-tuning process. And then this checks if the model has learned to better distinguish contrasting concepts. We can see that the weights are further apart from each other. Abstract reasoning presents the model with abstract questions related to the concepts and the training data. For example, is freedom the absence of oppression? And prints the model's generated responses. This provides a qualitative assessment of the model's reasoning abilities. This is what we're going to talk about very specifically when we get down into the testing phase. So in summary, this notebook fine-tunes a language model using a combination of contrastive learning and standard language modeling. The contrastive loss encourages the model to distinguish between ironic or incorrect statements and their corrected outputs, while the language modeling loss helps it generate coherent and accurate explanations. The evaluation section assesses the impact of this fine-tuning on common sense reasoning, semantic representation of contrasting words, and abstract reasoning capabilities. The key innovation is the use of the contrastive learning on the same model, not a Siamese network, using the incorrect statement as both the anchor and the negative, and the corrected statement as the positive example. Getting into the code, I had to install 2 packages here. So it's datasets and evaluate. And then with that, we load in the model, our 135M, and then this is the data set. And then so this is like my synthetic data set, very simple data set, right? So the sun is a cold, dark sphere would be the ironic statement. And then the sun is a bright and warm because it's a star undergoing nuclear fusion would be the truthful statement. Lies are the foundation of trust would be the ironic statement. Truth is the foundation of trust because honesty builds strong relationships would be the truthful statement. Success is measured by repeated failures would be the ironic statement. Success is measured by achievements because they demonstrate progress and skill. Hatred is the purest form of love. Love is unconditional and kind, while hatred is destructive and harmful, etc. So it's going through, it's just, here's like the incorrect statement versus, and the orthogonally incorrect statement versus the correct statement and the true grounded statement. And then so we're just training the model on that. We go through, and then again, there's a lot of work on the tokenization because we're splitting the tokenization and this process. So this input is like fed in as a different input than this, and so evaluated differently, right? So we have some special work that we put into there. And then we go through, and then we have our standard training loop, and then we have our tests afterwards, right? And then so we have our tests, like what is the common name for dihydrogen monoxide? It should answer water. What is the opposite of up? It should answer down. Where do plants get energy from? It should answer sun. What would you use to cut a tree down? It should answer axe. And what is the largest mammal on Earth? It should answer whale. And then we go through, and then the big thing though is we're testing, and then we do the word pairs. So hot, cold, truth, lie, freedom, and oppression. And we test how well the model separates those like semantic differences, semantic pairs. And then finally, we ask it abstract questions, like understanding, like, is the model like actually internalizing this, right? Is it doing anything on that level? So is freedom the absence of oppression? Can one learn wisdom through ignorance? And what is the difference between love and hate? And this is where it gets interesting to me, right? I want to focus on those last 3 questions because that's where the model responses, to me, show the most success with this overall training, even with this basic amount of training. And the third response to me is actually telling. So let's dive into it. So is freedom the absence of oppression? Freedom is the lack of oppressors. The absence or absence from oppression is freedom. And that's its full answer there. I cut it off at like 120 tokens. It's like I have to, again, this is very bootstrapped because of memory, right? And then it further says, what is freedom? Freedom is a state of being free from the control of others. It is not a condition of having and then I had to cut off its answer. Can one learn wisdom through ignorance? The answer is yes. In the first place, we are all born with a certain amount of wisdom. We are born knowing that we have a limited amount. This is the reason why we can't understand everything. But we also, had to cut it off there, what is the difference between love and hate? Love is a feeling of affection, and affection is an emotion. Hate is anger, and anger is an emotion. The difference is that love is more intense and hatred is less intense. What are the three types of love? So what you can see, I mean, what we very clearly see from these outputs is that this 135 million parameter model has pretty definitively internalized these first two questions, right? Is freedom the absence of oppression? It gives a very clear response that yes, it is able to very clearly articulate its response there, and I think it would give a very good response if we let it go through fully. Same thing with question number 2. Can one learn wisdom through ignorance? It takes a clear stance. Yes. Again, so these two questions are yes and yes. And then what is the difference between love and hate? It has absolutely zero idea. Even after this like training here, it doesn't know, right? Like it's and then our full data set here, right? And because like nothing in our data set gives like an AI model like that type of information, how is it going to know about emotions, right? So it's like, okay, yeah, like I like these other more abstract concepts. It has, I'm assuming, a lot more information in its base knowledge, and then that's kind of just what we're fine tuning off of here. And then, as you can see clearly, when we get to emotional questions, as far as like actual like internalization, like this is what I would expect, right? Like from fine tuning this 135 million parameter, simple, very simple and small model, these outputs, and then like so, you can run these and compare these to the base model on these questions, and very significantly and very simply, right? And you'll see the difference. Again, this is a small LM 135M, so it's like the most simple base model that they offer. And you can see very simple and very clear difference in the answers and the responses here, right? In the testing of our the accuracy pairs, like but I don't see significant improvement there, and I do see some improvement on the embeddings and the separation of the the hot cold concepts. So there is something that the model is taking in and internalizing from this training. It's just like this training, like what I'm doing here is so simple of like such a simplified version of this concept that I'm surprised that we're even seeing like something coming out of it, right? I would love to see this experiment times like 10, but I don't have the compute to pull off that experiment at the moment is where I'm at with this. So I'll leave this here. I'll leave a link to the description for this collab notebook. If anyone takes this further, like please hit me up right away, especially on this one. Like this experiment to me has been super awesome, and I would love to see this experiment with more compute. If you like this type of content, please like and subscribe. Thank you very much.